In this video, we'll be looking at how to find the volume of a solid of revolution using the washer method. You can see we have a drawing of a washer. A washer is a disc with a hole in the middle of it, so that we have the radius of the outside circle, which is the big disc. That's this capital R. And then the radius of the hole, or the inside disc here, that's the little r. And then we have the height of the washer, or the disc, which is h. Our axis of revolution for this diagram is shown here with this vertical line. And so you see that our radius is perpendicular to the axis of revolution. So we'll use the formula to find the volume of a washer. We'll take the volume of the big disc and subtract the volume of the hole, which is the center disc. So we have pi capital R squared h minus pi little r squared h. Or you can factor out the pi's and factor out the h's and get pi quantity capital R squared minus little r squared h. So our formula then, the volume of a washer, we can pull the pi out in front of our integral, and we'll integrate from a to b. Capital R of x squared minus little r of x squared dx. So to find the capital R, determine the function that's furthest away from the axis of revolution. And so capital R will be the absolute value of the furthest function minus the axis of revolution. And then to find little r, determine the function that's closest to the axis of revolution. And little r then is the absolute value of the closest function minus the axis of revolution. So let's do an example. Our example is to find the volume of the solid formed by revolving the region bounded by x minus 2y equals 0 and y equals x squared over 8 about the x-axis. So this is our axis of revolution. This parabola right here, this is the portion that we're dealing with. Notice I put in 2 for x and got 1/2. And then when I put in 4 for x, I got y equal 2. So those 2 points help me sketch this parabola. This was x equals 2y, and so y equals 1/2 x. So this is a line with a y-intercept of 0 and a slope of 1/2, which means up 1, right 2. So my region that I'm revolving about the x-axis is right here. I've drawn a representative rectangle here. You can see. I'm going to need to use the washer method because I have a hole. This would be my little r. So my little r will be x squared over 8 minus 0. And then my capital R will be from here down to my axis of revolution. So this is capital R. And it will be 1/2 x minus 0, which is 1/2 x. Now our formula for finding the volume of this solid then is we want pi times the quantity big R squared minus little r squared times, and then dx is the thickness of our rectangle, or the height. So our rectangle is moving from 0 to 4. That's 0.12. So we're integrating from 0 to 4. We have big R squared minus little r squared dx. So pi times the integral from 0 to 4 of 1/2 x squared minus 1/8 x squared dx. This is pi 0 to 4, 1/4 x squared minus 1/64 x to the 4th. So pi can remain outside. This will be x cubed over 12 minus, and this will be x to the 5th over 320, 0 to 4. Well, we have pi (32) over 15. And then when we put 0 in, we still have 0. So my answer is 32/15.